Yes. Hey, welcome back. Now let's solve the problem. Sum tree. And yeah, again, this is a bit difficult to solve if you don't know what recursion is. And first, let's go through the sum rather than going through the direct, what do you call, answer solution. So what is given? We are given a binary tree, which is important, binary, and we have to check if the what do you call each subtree is a sum tree for every node except the leaf node, and you have to return true if the entire tree is a sum tree also the return false. So they have conveniently given the definition of sum tree also. A sum tree is a binary tree where the value of node is equal to the sum of the nodes present in the left subtree and the right subtree. An empty node is also empty tree is also a sum tree. Yeah, that is important. That is one of our base cases. And yeah, and every leaf node is also considered as a sum tree. So what does that mean? So consider this example. You have 3 and 1 and 2. So what will happen? The left subtree of subnodes of 3 is 1, the right is 2, and when we add that, you will get 3. So it is a sum tree. But consider this example. You have 10, 20, 30, and 10, 10. So you may tell, yeah, this is also sum tree because the left node of the 10, left node of 10 is 20. Oh, no, no. Yeah, this is obviously not a sum tree, mainly because obviously as soon as you add 20 and 30, you will cross 10. And so what you can do is what you have to do, not you can do. You have to test out other kinds of inputs also. For example, consider this input. Uh, yeah, we just tried it over here. You have 5, you have 2 or 3, you have 2, you have 1, 2, and you have 1 and 1. So you might tell this is a sum tree mainly because the left nodes of 3, 5 is 3 and 2, and when you add 3 and 2, you will get 5. And when you add 1 and 2, you will get 3. And when you add 1 and 1, you will get 2. But in actuality, this is not a sum tree, mainly because you should not just consider the left and the right node, you should consider the entire left and the right subtree. So what is the actual sum of the root node of the sum tree of the root node? It will be 5. It will be equal to 3 plus 2 plus 1, which is already 5. And again, you will have 2 plus 1 plus 1, which is 4. So this value will become 9. And if it was a 9, then it would be a sum tree, mainly because now the condition holds true. No, no, if it was 10, so 10 would become 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it would hold true. But if it is a 5, it won't hold true because it should be the sum of the entire left node. So what we have to do is we will solve this recursively. So what we'll do is for each node, first we'll compute if it is the what do you call sum tree, and if it is a sum tree, then we will compute the entire sum and pass it down to the next recursive call, like its parent recursive call. And we'll just keep on repeating that until we get to the root node. And in the root node, we'll actually get the value of, like we'll actually get to know if it is a sum tree, or if it is not a sum tree, then somewhere else down the line only we would have written it is not a sum tree until and unless every node of the sum tree except the root node. And yeah, again, the complexity of this is O of n because we are just going through the entire tree once, and the space will be O of the 2 to the power of n. Now, height of the subtree, or yeah, all the nodes in the subtree only again will be O of n only, mainly because we technically use tag space, even though we don't use actual space. It's O of height of the tree, but we have to go through entire all the nodes once. So let's just do that. We have to have self over here because it's being called inside a class, and you have the node. So what we will do, we'll have the total sum, and the answer over here is actually recursion of the node value. Again, you have to have self over here, and you have to return the answer. Yeah. So now what I did I tell? So first now let's get rid of base cases. That is the most important thing to do when you're doing recursion. Yeah, that is the most important thing to do when you're doing recursion, and that is getting the base cases out first. So yeah, let's look over here. Empty tree is also considered a sum tree. So let's do that. If not, then it is a sum tree. So we'll uh, return the value of total sum, which is actually 0 because there is no node, and true because it is a sum tree. And a leaf node is also considered a sum tree. So what is a leaf node? If there is no, this is a leaf node. Again, you will return 0, comma, true. So what is the actual answer you are getting over here? You are getting the total sum and the, is it a sum tree? So yeah. So first we have to check for the left child. So let's make it left over here. Let's call it left total sum. Yeah. So and so by, so if it is left, then this will obviously be right over here. So right out, oh, oh. Yeah, right total sum will be equal to the value of node dot left, and this will be node dot right. So if by any chance left is not a sum tree, or by any chance if no right is not a sum tree, then obviously you have to do only one thing, which is return 0, comma, false. And so what is sum tree? What is the actual definition? Again, read the definition properly. Yeah, sum of the nodes present in the right and left should be equal to the sum of the actual node. So if node dot data, yeah, this is data over here. In some places like LeetCode it is val. If node dot data is not equal to the sum of these two, yeah, first correct the indentation. I think the indentation is gone over here. Let me just correct it. Yeah. So again, you have to return false along with some dummy value. Or else what you have to do, you have to return the value of this entire thing. Like you need the entire sum to calculate the parent sum. So for example, again, let me just copy the entire thing once. Yeah. Consider over here to calculate this value, you need the sum of the entire left and right subtree. So first you will check for 3, and for 3 you go to 1 and 2. So you can't just return the sum of 1 and 2 to 5. You have to also return the value of 1 and 2 plus 3 to 5. So that's what you have to do. So that is what is being done over here. Yeah. So you are taking the left subtree, right subtree, and the actual data value also. That is nothing but 3 plus 1 plus 2. No, it was not 3 plus 1 plus 2. Yeah, it was 3 plus 1 plus 2 to return to the value of, to check if the value is 10. And obviously, it will return true because it is a sum tree. Yeah, let us just compile and run it once. Yeah, I don't know what I'm doing. Since I'm using it inside a class, I have to have self over here. And yeah, it is false and false as expected. Okay, looks like I made some mistake. Let's go through the code once. So it is telling the actual input should be true, but I'm returning false. So why is that? That means one of these got hit. Not right is sum tree. Let me just, yeah, I'm doing the recursion on node dot left, node dot right. So if there is no node, or if it is a, what do you call, if there is no tree, then you are returning 0, comma true. Correct. and if not node dot left and not node dot right. So if it is a leaf node, then we are returning. Uh, okay, yeah, I figured it out. See, we should not return zero over here because we have to return the actual node dot data. Because just because it is a leaf node does not mean it will not have data. Just because it is a two does not mean the what do you call the value over there is zero. It's actually two. So now let us just check it out. It was 312, I think. Yeah, be careful of making blunders like that. Yeah, now it is true. Yeah, be very careful while writing code like that. I don't know why I returned zero. But yeah, the test case has passed. And if you want, you can clean it up also. Yeah, the one cleaning up you can do is actually you can just move this entire thing over here, and you have to have an or over here, and you have to obviously enclose these in parentheses. So that means that we can remove these two lines. But yeah, again, I think this can also be pushed over here. Again, don't forget to enclose them in parentheses. That is very important. But what will happen is you will get a null pointer exception over here if node exists, else you will return zero. They have left and right recursion, and then you're returning this part, and you're returning this part. So what you can do is you can directly return this part. Over here, it does not matter whatever the values. So you can directly return the first index because that is where you're having the actual logic. So let us just compile and run it once. Yeah. If you want, you can just clean up the code also like that. Yeah. And yeah, that's all for it. And thank you for watching. If you watched now, and yeah, goodbye. Grandmother DK. I know you can do it. I believe in you. And peace out.